Hey guys, it's Angel, and we're going to be going over question 4, which asks, what is the relationship between the two structures? Now, when you first look at these problems, they can be a little intimidating, but they're actually relatively straightforward. And so what we're going to want to do is we're going to figure out the conformation of each one and determine whether they're cis or trans, determine where the branches are coming off. And so for this first one, we're going to take a look at this first carbon that has a methyl group coming off. And so that first carbon would be in the axial position, that methyl group would be in the axial position, because if it were going off to the side like that hydrogen, that would be in the equatorial position. Now our second carbon back here, represented by the circle in the back, also has a methyl group coming off of it, and that is going off to the side, so that would be the equatorial position. If it had been going down like this hydrogen here, that would have been the axial position. So we've already knocked out our first one, and we 1,2-AE is cis. If you refer back to the little table that you got in class, you'd realize that that is cis. It's really good to try to memorize that table, come up with your own mnemonic to do that. It'll be really helpful in the end. And so for the second part, we've got the same thing. We got 1, and we've got the methyl group going off to the side. So we've got 1 equatorial, and then the second carbon also is going off to the side, so 2 equatorial. Just as a reminder, if it had been going up, that would have been axial. If this had been going down, that also would have been axial. But we've got 1,2-EE, that is trans. And so cis and trans are stereoisomers. Let's go ahead and take a look at the other options, just so that we can talk about why those were not the correct answers. And so for structural isomers, well, here we have a 1,2 dimethyl cyclohexane. And also, over here we also have a 1,2 dimethyl cyclohexane. So structurally they are the same compound. Conformationally they are not. And so if it had been a 1,3 dimethyl cyclohexane versus a 1,2 dimethyl cyclohexane, that's where you would get structural isomers. However, that is not the case here. So for C, different drawings of the same conformation of the same compound. So I'm going to go ahead and draw this in a chair perspective just to switch it up on you guys, get you some practice with this. If we were doing the same compound, we'd have to have the 1,2 or 1,3 or 1,4 on both structures. And for this we're going to go ahead and just do 1,2. And we want the same conformation, so we essentially want the same AA or the same EE, but in different drawings, because that's the only thing that's different is the drawing. So here, for example, on the first one, we're going to do an equatorial position. So 1E, and for the second part, we'll also do an equatorial position. So this would be a 1,2-EE, which is trans. Now what we're going to do here, because it has the same conformation on the same compound, we're just going to draw it differently. And so instead of, we're still going to have the 1,2, but now we're going to draw the equatorial here, and instead we'll draw the equatorial here. And so we have 1,2-EE. Notice it's the same conformation of the same compound, different drawings. Okay. So now for the last one, it's asking for different conformations of the same compound. So this is where we would have the same compound again, so it would still be 1,2 trans or cis versus 1,2 trans or cis, but we're going to have different conformations in this case. Okay, so what we'll do is go again with trans, and so we'll have E for the first one, trans, but now we're going to have different conformations. So what we're going to do is still get the 1,2 trans, but we're going to get that this time by doing 1A, 2A. And so 1,2AA is also trans. So these are the same compound, different conformations. All right, guys, hope that helped.